So do the multiplication, 480 times 0.083. I end up with 40. And my units are kilometers. My hours cancel top and bottom. And I'm left with kilometers, which makes sense. If your units don't work out, then you have a problem. And I'm traveling east. So I put in my little east here. Just for fun, let's say I did this incorrectly. I went distance was 480 kilometers per hour. And then I multiplied that by 5 minutes. So 480 times 5, not really interested in what that is, but notice what happens to my units. I would have something, kilometer minutes divided by hours, which is a really, really strange unit. Nothing we'll ever talk about will be in kilometer minutes divided by hours. So you don't want to do that. Make sure your units match up and you end up with where you want to go. 20 minutes or so left, and it's not going to be enough time for section 8.3. Maybe I'll just look at the learning guide here and we'll see where we're at. So you guys should be good up to the relative velocity. So yeah, we should be good up to page 5. We haven't done graphing motion yet, and graphing motion will be 8.3. You guys can do all the graphing motion stuff. You shouldn't have any problems with it because we've covered it all in math already, but there's some kind of things that won't make sense probably until we talk about it. So if you want to continue on ahead, that's fine. You should do absolutely fine with the graphing motion stuff. But that's kind of where we're at in terms of these questions. So you should be good up to page 5, the end of page 5. The beginning of next class, we won't meet next week. I won't see you guys again for a whole nother week. It's a long, long, long break. Next week, you guys will have social studies and then you're doing the walking tour of downtown. And yeah. Does anybody have, I know Mrs. Wood had sent out some course information for you guys, and most of you who are continuing on in our grade 11 program picked your courses. If you're going to one of the schools in the wherever you're living next year, you've probably done a course selection thing with that school. But does anybody have any questions regarding the courses, physics, biochem, earth science, in general? I know you've probably talked about it a little bit in planning, but I mean, we've talked about it a bit today and we have some time. I only got a survey about what courses. Yeah, that's probably all you would have received. And then you kind of filled out the little, well, there was a questionnaire. She might not have sent it out yet. There might still be to come. So yeah, if you had any questions about that stuff, or jobs, or university prerequisites, or anything like that. Have I chosen the sciences I'm going to teach? No. We are kind of waiting to see which sciences people choose in order to pick one that is going to kind of service the most amount of students, because just the way the timetables work and how funding works out, I can't teach a course with like 2 students in it. I would love to teach a course with 2 students in it, but it's just not financially viable. So we're kind of a little bit have our hands tied a bit with what courses we can do. I'll be doing one for sure out of the big 3, so chem, physics, or bi. Probably chem or physics. I don't know that for sure. If you wanted to take 3, you'd likely do a couple through Central, sort of more correspondence style than what we've been doing. Is the survey determining what courses you offer? A bit of both, Ava. If everybody decides they want Physics 11, then I'll teach Physics 11. If only one person wants Physics 11, then we're not gonna teach it. You'll have to take a correspondence. So I don't want to, get myself too deep in the mud here by saying, hey, if everyone says we want this, we'll do it. That's just not a reality. There's a lot of moving parts here. So it's not just a matter of people saying what they want and then we offer it. You need to decide what you want based on working backwards. So if you plan on attending university, you need to say, okay, first year university, I want to be a botanist or whatever you want to end up being. So sort of think of a career path. And you don't have to pick a specific career, but you should identify an area where you want to go and then kind of work backwards. Okay, I want to work as an engineer. I'm really interested in electricity, electrical engineering. Work my way backwards. Okay, I need to take physics, I need to take chemistry to get into that program. So I'll need to take physics and chem in grade 11, physics and chem in grade 12. So there you go. You end up with, biology is not easy. It's a lot of concepts, a lot of memorization, not as much process-oriented as like physics or chem, for sure. So that's kind of one of the considerations we're making with the courses we offer. Biology would be a really great course to take through correspondence because it's a lot of you reading. There's not a lot of process stuff. So it's like, talking about sea sponge. How does a sea sponge work? Well, it has all these cells and the cells go together to form an organism and it's in this phylum and this kingdom and things like that. So that's kind of something that you could definitely do through correspondence, a lot easier than something like physics or chem. So that's kind of where we're at. Do you guys offer chem bio as like one course? No, you have to do chemistry and biology separately, 2 separate courses. And remember, you don't have to take 3 sciences, or you don't even have to take 2 sciences. You need a science in grade 11 to graduate. If you're going on to maybe do an arts degree, maybe you're interested in English or things like that, maybe you don't want to go to university, you just want to go to trade school, or maybe you just want to get a job and start working. You don't need to take 3 sciences for that. I have a physics degree. I went to university and got a science degree, and I only took 2 sciences in high school. I took chemistry and physics in grade 11 and 12. So I didn't take biology until I made it to university. And, 2 sciences was enough to get into university when I went. That's all I took. And then I took a bunch of biology when I was in university. So there you go. If you're going to take physics 11 and 12, calculus doesn't really need to be a part of your course selections, but calculus is really great if you plan on doing physics or chemistry in university or pursuing any sorts of math. So basically, calculus in grade 12 is an elective. It doesn't really count as a math credit. It doesn't count as a science credit. And it's just a bunch of stuff you're going to learn in university. So it's basically like a first-year university. The first half of first-year university math is calculus. So you learn a semester's worth of university just to kind of get you ahead. So calculus and pre-calculus are different. Ideally, you'd take pre-calc 12 first semester, and then you could take calculus second semester. But I don't want to overstep here, but I don't think there's any courses in university that will require you to take calculus to get into them. A lot of courses would suggest you take calculus. It'd make your life easier, but you don't have to take it. I took calculus when I was in high school, and it didn't really, it was good to know it, and I took calculus when I went to university, but there was lots of students in my class who didn't take calculus in high school and still did fine in university. So we'll definitely be semestered again next year, Taylor, for sure, semestered. It's just to line up with the timetables of schools and things and scheduling. So that's that. It doesn't seem like there's any other questions. We won't see each other again until, I might come climbing on Friday if you guys are interested in that. Lots of fun. Walking tour next week. I don't know what I'm doing. I might partake if I'm not teaching. That'll be fun. And then I won't see you guys again for until the following week. So I think it's June already, or maybe the end of May or something. Crazy. Time flies. So basically we have 8.3, and then we have 2 sections in chapter 9. 2 sections? There's basically 3 or 4 lessons left, and we're done. So we're going to finish with about a week's worth of review time left, and we'll start to organize that. You guys can come in if you have questions. I'll get some practice exams out to you guys so you can start doing that the next time we meet. Seems really early, but that gives you a month to start reviewing. So we'll start looking at some practice exams next time we're together. The provincials, I don't know the date. It's on the end of June. I think it's the 24th or something. Yeah, thank you, Anna. Is there assignment for Unit 8 and 9? We'll probably do one assignment for Unit 9. On June 8th, we're going to go to KSS. And if you come to KSS on June 8th, we're going to do a lab. And that will count for your assignment for Unit 8 and 9. If you don't come, then I'll give you one to do online. So it gives everyone a chance to kind of do it. You want the model exams because it forced me to study one. Yeah. Abby, you had some questions about chemistry. So that's all I have to say for physics and course selections and all that. So if you want to take off, we'll see you later. Abby had some questions I'd be happy to go through now if you want to fire them in, or I can go to a learning guide or whatever you want. And we can go through that. We have a bit of time now. So if not, have a great afternoon, guys. We'll see you in a couple weeks. So long. And then we'll start reviewing and finish up this physics stuff. But for now, chemistry review. And most of you will be stumbling into the Module 2 exam eventually, so might benefit from looking at some questions. And if you don't want to type them out, if it's something I can just go look at online too, Abby, you can just say, hey, go look at this, or see where you're at. The learning guide's all loaded up, ready to go. Should you memorize compounds for things like glucose and table salt? Yes. Those are kind of really common ones. Things like, you should know what acetic acid is, which sounds really weird. There are some acids in your learning guide. So acetic acid, here nitric acid, sulfuric acid, hydrochloric acid. You should, I've just highlighted behind my head. There we go. You should know where all of those things are in your learning guide. You should know the basic, basic hydrocarbons. So you should know what methane is. CH4. You should know what table salt is, or just NaCl. Glucose. I want to say yes to glucose because it turns up in the biology unit and it turns up in the chemistry quite often. C6H12O6, I believe. Hopefully I got that right. So there's glucose, you should know that one. Diatomic elements. Well, at least you did it there, Ava, instead of somewhere else, like a provincial or somewhere where it's important. Yes, and acetic acid is in the data booklet, so CH3OH. I think it's written differently in your data book, but it is there. So these are kind of really common things. Just like when we say water, you know what water is. You know it's H2O. It's just really common, so you've memorized it. Well, to scientists, things like methane, it's really common. CH4, you should know what it is. Table salt, NaCl. These are kind of just really common things to scientists. Should you memorize the strong acids? Strong bases have elements from the first two columns in the periodic table and usually do two. Strong acids and then other acids you could safely assume to be weak. I don't know, Ava. I want to say no. Don't worry about strong acids or strong bases. It's a chemistry 11 and chemistry 12 concept. I want to say chemistry 12. As long as you know the common acids out of the data booklet in Unit 4, so hydrochloric, sulfuric, nitric, acetic, you should be okay in terms of Science 10. So you get those, that's good. Do I need to know how to name things like cyanide that doesn't have an in ite or ate? I'm not sure what you mean by that, Abby. When we're talking about cyanide, it's one of the things that's on our common ion sheet. So there are a few things on the common ion sheet that end in ides, but you can just look them up, like hydroxide, cyanide. I think those are the only two. So I guess when you're doing your kind of naming, we talk about like sodium chloride, and we see a chloride, and we think, okay, chloride is chlorine, I look up Cl, it's there. But cyanide isn't on the periodic table, it's not an element, it's carbon and nitrogen bonded together covalently. So naming rules for polyatomics. Well, in general, right, for polyatomics, we're not going to change the ending of the name. So if it is NaClO3, that is sodium chlorate. It could be NaClO2, that's sodium chlorite. We could have NaCN, sodium cyanide. So we never change the endings of our polyatomics. We only change the endings of non-metals, and they always get changed to ide. With acids, it's different. You get your eights go to ic, and your ites go to us. Those are the acid naming rules. So there's three types of acids. You have an acid in polyatomic, it's either going to be an ic or an us. You have an acid with just a non-metal, it's going to be hydrochloric acid, hydrofluoric acid. The ides. Hydrocyanide, hydrocyanic, hydrocyanous. I don't know that that'll happen. There's only two of them. You can't put H and OH together because that's just going to give you water. So that wouldn't happen. I don't know what HCN is called. That would be the only exception to the rule, HCN. I'm sure you could Google it. I don't know what it would be called, to be honest. It's not something that's ever really come up before, but it is an excellent question. HCN. Let's just Google it right now, see what it's called. Hydrocyanide, hydrogen cyanide. Here you go. It has a common name. Prussic acid. So it is definitely an exception to the rule. I've never really encountered it before, so hopefully you don't ever encounter it either. It doesn't even look like it has fromic acid, hydrocyanic acid. So it gets the hydro, and this is a common name, and this is a common name. So hydrocyanic acid. So it looks like it gets named like just HCl would or HF, things like that. Weird questions, but good questions. So those would be the only two scenarios. You'd have water or you'd have hydrocyanic acid. Anything else? Any other fun chemistry questions? Feverishly typing. Look what I started. You guys are writing paragraphs. Lately, we've been watching a lot of wildlife documentaries. Eva, I love your comments. So sciencey. And they talk about what ocean currents do to the land. Are you talking about like El Nino, La Nina sort of currents, or talking about like the deep ocean currents where? Yeah, like in terms of climate change and ocean currents, and there's lots of really cool stuff about frequency of El Ninos and La Ninas and how they used to. Okay, Abby. As the ocean used to be fairly consistent in terms of temperature, and then we had a few El Nino, which was warming, and then it'd be normal, warmer, colder. But now it's every year is an El Nino or a La Nina. So it's really does a lot of interesting things, scary things to the atmosphere, which is another section that's in Science 10, but they took it off the provincial, so we don't often get to it because there's not often enough time. All right, I think you're good, Abby. Ava, you're going to keep getting smarter watching all these documentaries, which is great. Everyone else, I think we'll probably leave it there for today. See you guys in a couple weeks, and obviously get as much done as you can. You have a little break from me. So I hope you guys get outside and enjoy some of that nice weather. Today doesn't look like it's going to be that great for the weekend. Yeah, specifically some of the temperate rainforests that we talked about in class, unique because of their proximity to ocean currents and jet streams, which ocean currents drive jet streams in the atmosphere. Lots of connections here, Ava. I like it. Yeah, and think about us, right? That's why we're so dry in places like even like into the prairies in Calgary and things like that, rain shadow that the Calgary area receives. They get some Chinooks in the winter, really warm temperatures and things like that. Pretty cool stuff. So there you go. Have a great one, guys. We'll see you when we see you. Thanks, bye.